Section 2.3 involves solving equations using the distributive property. So first we're going to review what the distributive property looks like. And with only algebra, it looks like this. A times the quantity B plus C is equal to A times B plus A times C. So what we're doing is we are distributing the A to everything inside the parentheses. What that looks like with numbers involved, here's an example. We could have 5 times the quantity x plus 3. So we are going to distribute the 5 to the x, so it would be 5x. And then we're going to distribute the 5 to the 3, and I would have 5 times 3. And then after that, I'm going to simplify 5x plus 15. So taking a look at these examples, when it says simplify, that means your answer shouldn't have any parentheses in it. So we're going to distribute the 12 in front of the parentheses to the 2x and to the 3. So it's going to look like 12 times 2x plus 12 times 3. So we give the 12 to both parts of the parentheses. So 12 times 2x is 24x, and 12 times 3 is 36. And that's the simplified version of the original problem. This applies to fractions, and we did some prerequisite work with our fractions, so hopefully this will become a little bit easier for you now. We are going to distribute the 20 to the 3/4x. So it's 20 times 3/4 x. And then we're also going to distribute the 20 to the 1/5. So it's 20 times 1/5. And if we apply what we learned in the prerequisite material, we're going to put the 20 over 1. We are going to look for the diagonals to cross cancel. So 20 and 4 have a common factor of 4. 4 becomes a 1, and 20 becomes a 5. 4 goes into both of those. So now I have this 5 times this 3 times x. So 5 times 3 times x is 15x. And now let's take a look at 20 times 1/5. So I already put the 20 over 1. I'm going to look at the diagonals to see if it cross cancels. 5 goes into both of those. 5 goes into 5 once, and 5 goes into 20 4 times. So now I have 4 times 1, and that is 4. So that is my simplified version of the original problem. Alright, let's go into some examples of equations that use the distributive property. So number 1 here, we're going to distribute the 3 throughout the parentheses. So we're going to have 3 times 5x, and we're going to have 3, I'm going to change this minus sign to plus and negative, so it's going to be 3 times negative 2 equals 39. Oops, sorry about that, 39. Alright, now that we have that, we're going to simplify. So 3 times 5x is 15x, plus 3 times negative 2 is negative 6, and that equals 39. Let's draw our line. And at this point, hopefully this from here on down becomes much easier for you because we've been practicing this stuff a lot. So I have a -6, which is the same as a -6. So I need to add 6 to both sides. The 15x drops down. The -6 plus 6 cancels. And then over here, I'm going to have 45. 39 plus 6. And then my next step is to divide both sides by 15. 15 over 15 is 1. So that's 1x. And then 45 divided by 15 is 3. And that is the simplified answer. So I am done with the problem. Moving on to number 2, I'm going to distribute the 7 to both numbers inside the parentheses. So I have 7 times 2x plus 7 times 5 equals 161. So 7 times 2x is 14x. Plus 7 times 5 is 35, and that equals 161. We are ready to solve, so now I'm going to get rid of the plus 35 by subtracting 35 from both sides. The 14x drops down. 35 minus 35 is 0. 161 minus 35 is 126. And my next step is to divide by 14. The 14 divided by 14 is 1, so I'm left with 1x. And 126 divided by 14, you would use a calculator for that, and the result is 9. So x equals 9 is the solution. One other application of the distributive property is to work with problems that have fractions. And if you have fractions, you can use the distributive property to get rid of them. All we have to know is the lowest common denominator. So if you take a look at example 3, I'm going to make all of those numbers fractions. So I'm going to put -20 over 1 and the 7 over 1. So now I have all fractions. I look at the denominators. Remember, the denominators are the bottom. So I have a 1, a 2, and a 1. So the lowest common denominator is 2. So let's write that off to the side. The LCD is 2. So what I need to do is multiply everything, both sides, by 2. So I'm going to multiply 2 times -20. And on this side, I'm going to multiply 2 times the whole side, x over 2 plus 7. Now, the reason I'm doing this is to get rid of the fractions. So let's figure this out. 2 times -20 is -40. And on this side, I need to use the distributive property. 2 times x over 2 plus 2 times 7. I'm going to put this 2 over 1, and I'm going to look to cross cancel here. So I see 2 over 2. 2 goes into both of those, so that's 1 over 1. Alright, so I have successfully gotten rid of the fractions. I have -40 on this side equals, and all of this canceled out to be a 1, so I have just 1x plus 2 times 7, which is 14. I am going to subtract 14 now from both sides. And negative 40 minus 14 is negative 54. The 14 minus 14 is 0, so I'm just left with x there. So my answer is x equals negative 54. Let's move on to example 4. So with example 4, we have x over 2 plus 4 equals 5 minus x over 2. So I'm going to start by putting 4 over 1 and 5 over 1, so I have all fractions. And the LCD for this one, we have 2, 1, 1, and 2. So the LCD, that's the lowest common denominator, is 2 again. So I'm going to multiply both sides of the equation by 2. So I'm going to multiply this side by 2. 2 times x over 2 plus 4. And on the other side, I'm going to be doing 2 times 5 minus x over 2. Alright, this time I have to use the distributive property on both sides of the equal sign. So I distribute the 2, and I'm going to erase some of the previous work here to give me more space. Alright, so if I distribute that 2, I'm going to have 2 times x over 2 plus 2 times 4. On the right-hand side, I'm going to distribute the 2 to both parts of the parentheses. So I have 2 times 5 minus 2 times x over 2. Alright, now it's time to look for cross-canceling. So here we have 2 over 2, which cancels, and we're left with x. Here we have 2 times 4, which is 8. On the right-hand side, we have 2 times 5, which is 10. And then here, I'm going to put that 2 over 1. Look at the diagonals. Those cancel. So I have minus x. Now this problem looks like section 2-3 examples. I'm sorry, 2-2 examples. So we need to get the variable on the same side of the equal sign. So I'm going to take this minus x right here, and I'm going to add an x to get it to the other side. So I'm going to add x to both sides. Now, what you need to understand is if you have just a simple x without a number in front, the number in front is always 1. So here I have 1x plus 1x, and that result is 2x. So now I have 2x plus 8 equals 10, and the minus x plus x here cancels. I'm going to subtract 8 from both sides. So I have 2x, the 8's cancel, equals 2. And my last step is to divide both sides by 2. So x equals 1 is the solution. Alright, one more example. And this last example has different denominators. So I'm going to put that x over 1. So the denominators are 5, 1, 10, and 2. So the LCD, the lowest common denominator, is 10 because all 4 numbers go into 10. So that means I'm going to multiply both sides by 10. 10 times 4/5 x minus x equals 10 times x over 10 minus 9/2. So we're going to distribute the 10. So I have 10 times 4/5 x minus 10 times x equals 10 times x over 10. I'm distributing over here, minus 10 times 9/2. We're going to now look to cross cancel. So 10 over 1, 10 cancels with 5. 5 goes into both of those. So now I have 2 times 4 times x. So 2 times 4 times x is 8x. Here we have minus 10x. On this side, I put the 10 over 1. Look to cross cancel. 10 goes into both of those. So we're just left with 1x. And 10 over 1 here, the 10 and the 2 cancel, and I'm left with 5 over 1 there. So now I have to do 5 times 9, and that's 45. Alright, so the first step is distributive property. Then we're going to look to combine like terms on the same side of the equal sign. So 8x minus 10x is negative 2x. Alright, then I need to get the variable on the same side of the equal sign. So that means I have to get this 1x to the other side, so I'm going to subtract 1x from both sides. So now here, negative 2x minus 1x is negative 3x. 1x minus 1x is 0. And I'm left with negative 45 because this minus sign right here is still with that 45, so it's negative 45. And the last step is to divide both sides by negative 3. So that leaves us with 1x here equals a positive 15 here. So x equals 15 is the solution to number 5. And that summarizes section 2.3, solving equations using the distributive property.